Okay, so today I'm just going to teach you a shortcut for factoring special products. Does not mean you have to use it. You can use the other factoring method, but if you want to make your life a little bit easier, then use this shortcut. Plus, it would be really, really good if you could start to recognize when a polynomial is a special product, okay? So, let's start with, here's how we're going to determine if we have the special products even at all. If a binomial or a trinomial starts, I will say begins and ends, so in a binomial it would be both terms, in the trinomial it would be the first and the third. If the binomial or trinomial begins and ends with a perfect square, what does that mean, perfect square?
Itself.
Something times itself would get you that perfect square, right? In other words, whenever you multiply something times itself, the result has to be a perfect square. Okay? So if it begins and ends with a perfect square, notice what it says here. It is possibly, not always, but it is possibly a special product. And when it's a special product, it would be nice if we could recognize that, because factoring it will be a little bit easier, plus there's just special things about special products that we need, we're going to have to do, if not this year, in other years in the math. Okay, let's talk about some perfect square numbers then, so we can recognize perfect squares. 1 is a perfect square because what times itself is 1? 1. Okay, what's the next perfect square? 4, because 2 times 2. What's the next perfect square? 9, because 3 times 3 is 9. Okay, go ahead and finish all the way until you fill every little empty line I have there. If you don't have these memorized yet, I would highly suggest that you get them memorized, because that would be very useful in your math memory. And this is only through the first 10 integers, positive integers. 1 through 10 squared. Anybody know what 11 squared is? 121. What's 12 squared? 144. What's 13 squared? 169. What's 14 squared? Just split those two numbers around. 196. And 15 squared is?
200.
225, 225, not 200 something, but exactly 225. It would be good to get even those memorized, those other extra 5 that we didn't list here. Okay, let's talk about perfect square variable parts, because you know what? Usually the first term has a variable part involved with it also. So how will we know if we have a perfect square first term if it has a variable part? So is x squared a perfect square?
Yes.
Why? Because x times x is x squared? Okay. What would the next perfect square? X to the 4th. Because?
Because x squared times x squared.
Because x squared times x squared is x to the 4th. What would the next one be?
X to the
No, x
X to the 6th. Because remember, when we take x to the 3rd times x to the 3rd, what do we do with the exponents?
You add them.
We add them, not multiplying, we add them. So what would the next one be?
x to the 8th.
X to the 8th. Oh, I'm starting to see a pattern here.
Yeah.
What is it?
So you go up by 2 every time.
You go up by 2 every time. The even numbers are perfect squares, aren't they?
Yeah.
On variable parts. So x to the 10th, x to the 12th, and so on. Right? So tell me then, if we were going to find the square root of x to the 12th, what would we have to do? It's as simple as doing what?
Just dividing the exponent in
Yeah, just dividing the exponent in half. Half of 12 is 6, so we would say the square root of x to the 12th is x to the 6th. Yeah. Okay, so this is going to help us be able to recognize perfect squares, whether they are just numerical or they are algebraic. Okay? So now let's set up some rules for when we know we have a special product. So if it is a binomial, What's a binomial again?
Two.
A two-term polynomial. If it is a binomial for which both terms are perfect squares, it has to have subtraction. It has to have subtraction. Can anybody tell me why they think it might have to have subtraction? If it's a binomial, or if in other words b is 0, that means the x terms
Would.
disappeared. That means opposites were added together, they canceled out. So that means I would have had to have a, what? Positive one of them and the negative one of them. And what happens when you take a positive times a negative? You get a negative. So our C value has to be negative, doesn't it? So it has to have subtraction. So we have this binomial. The first term is a perfect square, the other term is a perfect square, and there is subtraction between it. It is then called the difference of two squares. Or sometimes they just leave the word 2 out and say difference of squares. Examples. X squared minus 25. Does it pass the test?
Yes.
Because
It's a binomial.
it's a binomial. And it has,
Positive and a negative.
okay, so what operation does it have to have? Subtraction. It has subtraction. What else does it have to have? Perfect square at the beginning and at the end. And are x squared and 25 both perfect squares?
Yes.
Okay. How about 4x squared minus 81? Does it pass the test? Okay, because it's a binomial with subtraction. Is 4x squared a perfect square?
Yeah.
What's its square root then?
2x.
2x. Okay, and is 81 a perfect square? Yes, and its square root is 9. How about 9 minus x to the 4th? Does it pass the test?
Yes.
Because it is a binomial with subtraction. Is 9 a perfect square?
Yes.
What's the square root of 9?
3.
And is x to the 4th a perfect square?
Yes.
Yes. How do we know?
X to
The exponent is even. As long as the exponent is even, it's a perfect square. Because it's divisible by 2. Okay? So the square root of x to the 4th is what?
X to the second.
X to the 2nd. The exponent is even, yes. Okay, now what if we have a trinomial? And this trinomial begins and ends with perfect squares. Here's the test it has to pass. Besides starting with a perfect square and ending with a perfect square, the last term must be positive. We have to have a positive C value. It can end in subtraction. And the middle term has to be twice or double, if you want to use the word double. Because you remember when we were multiplying, how we multiplied times 2? So twice the product of the square roots. And those square roots come from the square root of the first term, that is a perfect square, the square root of the last term, which is a perfect square. So examples. X squared plus 4x plus 4. Okay, first thing you have to look for is the beginning a perfect square and is the end a perfect square? Is x squared a perfect square? Okay. Is 4 a perfect square? Okay, the next thing you want to look for, don't even go through any more work until you look to see, is your C value positive? Okay? Now you can run it through this next test, which says take 2 times the square root of the first term times the square root of the last term. This is kind of like a little test, and of course, you'll get to the point that you're not going to write this out every time, but you're going to run it through this test in your head. So we are really going to take 2 times x times 2, right? Because the square root of x squared is x, and the square root of 4 is 2. And what is 2 times x times 2? 4x. And that is what our middle term is. That's what we want it to be knowing. So we would say this is a perfect square trinomial. How about x squared minus 4x plus 4? Does it pass the test? Does it begin with a perfect square?
Yes.
Does it end with a perfect square?
Yes.
Does it have a positive c value?
Yes.
Then we'll just run it through the test again. 2 times the square root of x squared times the square root of 4. But you're gonna, yeah, you guys are gonna think it's not, but wait a minute. Doesn't 4 have another square root?
It would be the -2.
Isn't a negative 2 times a negative 2 also a positive 4?
Yes.
Oh, so we could use the negative square root of 4. So is 2 times x times negative 2 4x?
Yeah.
So does that match our middle term?
Yeah.
Yes, so this is a perfect square trinomial also. So on this front side, all we were doing is talking about how do you run it through the test to determine if a binomial is a special product, called the difference of squares, is a trinomial a special product called the perfect square trinomial. Anybody have questions about those tests? Okay, then let's go to the back side. And let's talk about how we can shortcut it then. If it is the difference of two squares, you've determined it is. By the way, maybe some of you are a little confused by what does it mean by only 4 get a no.
Means it doesn't.
It means they're not special products, yeah. 4 of them in your homework cannot be factored because they are not special products, nor could they be factored using the other method. So you would get to say no and you get to move on. Okay, if it is the difference of two squares, each binomial factor will begin with the square root. So we're starting to just decide what would the factors look like. So the first term of the binomial factor will start with the square root of the first term. It will end with the square root of the last term. And looking on your homework at the last problem that you had, tell me, what do you think should happen then? What else?
To be the easier.
One would be, are they going to be matching binomial factors?
No.
Okay, one's going to have
Negative.
subtraction and the other is going to have addition. So I'm going to say addition first with addition in one and subtraction in the other. So in other words, when b is 0, you've decided that their whole terms are perfect squares. It adds subtraction like it's supposed to. Then you can do this. The square root of x to the 8th, what is that?
X to the 4th.
X to the 4th. The square root of 64, 8. What's the other test it has to pass? They're perfect squares. What other test does it have to pass?
One has to be addition.
No, what has to be true about the binomial that we're factoring? Look at the front of
It
your
has
hat.
to be subtraction.
It has to be subtraction. Do we have subtraction?
Yes.
Yes.
Yes. This is important also. If it was addition, do you think we could do it?
No.
In other words, could you take something times itself, a binomial times itself, and end up with b being 0?
No.
The o and the I step, would they cancel each other out?
Other than
They wouldn't, yeah, they would just double, wouldn't they? So we are going to say then that our factors are going to be, they're both going to start with x to the 4th. They're both going to end with 8. But they're not exactly alike. One has addition, the other has subtraction. This is its factored name. Now, when you tried to diamond method this one, you might have been a little confused because of the x to the 8th, right? But you really could use the diamond method for this one also. You just would have to say to yourself, wait a minute, I know that my binomial factors have to start with what do I have to multiply by itself to get the first term. Okay, How about this next one? 3 squared minus 16x to the fourth. Before we even go through all the work, let's just run it through the test. Is 3 squared a perfect square?
No.
No.
Yes, it is. It's 9.
Anything being squared is a perfect square, folks. How about 16x to the fourth? Is that a perfect square?
Yeah.
Yes, because the numerical part 16 is a perfect square, x to the fourth is a perfect square because it's an even exponent, right? Isn't that the only test the variables have to pass? Is their exponent even and it has subtraction? It passes the test. The square root of 3 squared is?
9.
No, 3 squared is 9.
3.
Oh. The square root of 16x to the fourth is?
4x squared.
4x squared. It has subtraction. We already decided it is a perfect square. It is a special product. It is a difference of squares. So now we should be ready to set up our factored name. How will it look?
3x plus, 3 plus 4x to the second times 3 minus 4x squared.
Okay, is order gonna matter?
No.
Uh-huh.
Well,
If you mean for the subtraction and the addition.
yes.
Okay, yes, these two binomials can trade places, but can the terms of the binomials trade places?
No.
No, it could in this one, in the first one, couldn't it? Because it's addition. But it's really, really important that it doesn't change places in this one because that's subtraction. And it's supposed to start with the square root of the first term and with the square root of the second term with subtraction between. And we cannot flip subtraction around. So just keep it in the order it is and don't worry about that those binomial factors are not in standard form. It's okay. So questions about the shortcut for factoring binomials that are special products. Difference of squares. Okay, well those are the ones I love to factor. They're the easiest of all. Okay, let's go on to, well, what if you have run it through the test and it is a perfect square trinomial? You've determined it is. How can you shortcut this one? Well, each of your binomial factors will begin with the square root of the first term. Seems like there's a lot of square rooting going on here today. And it will end with the square root of the last term. So it's already passed the perfect square trinomial test. We have decided it is a special product. So we can take the square root of the first term. We can take the square root of the last term. If the middle term is positive, those binomial factors will match and they will have which operation?
Addition.
Addition. If the b is positive, that means there's addition. This is like problems number, when we're looking at problems 1 through 4 on that homework you did for today. When the binomial factor had addition, did the b value turn out positive? Look at your homework. Didn't it?
Yeah.
And what happened when you had subtraction in the binomial factor? The b value turned out negative, so both will have subtraction, or in other words, that binomial times itself will be subtraction when b is negative. So again, this is saying it's already passed the perfect square trinomial test. So now this is what you should be able to do. Take the square root of the, so first we've got to decide if it passes the test. Is 9x squared a perfect square?
No.
Okay. Is 1 a perfect square?
Yeah.
Okay. So what is the square root of 9x squared?
3x.
Okay, let's just start that at least. And what is the square root of 1? 1. Okay, so remember what we have to do. We have to take that 3x times that 1 and double it. 3x times 1 is?
3x.
3x. Double that?
6x.
6x. Is there a 6x in the middle?
Yes.
Okay, it's a perfect square trinomial, isn't it?
Yeah.
Okay, so that means we are going to have a binomial times a binomial that both start with 3x, both end with 1, and both have what? Addition, because the b value is positive. So again, just like the homework did, when you had to do multiply, it started it like this, didn't it? That's the shortcut way of writing 3x plus 1 times itself. this is its factored name. Without having to do the diamond and factoring by grouping. Because is that what we would have had to do on this one?
Yeah.
Yeah. Okay. How about you try number 4 then? First, maybe you could just start by doing this, deciding if you really can take the square root of those first and last terms. And then if you can, does it pass the other test? Oh, by the way, we got to make sure we point out this. What has to be true for it to be a perfect square trinomial? We forgot to check this test. What has to be there? A positive. Okay, passes it, doesn't it?
Yeah.
Okay, it has to pass that test also. Is it a perfect square trinomial?
Yeah.
Okay, why?
Because the first and last numbers are squared.
Okay, what is the square root of 36x squared? It's 6x. And what is the square root of 9?
3.
3. Now how else are you going to check to see if it passes? Multiply 6x times 3 and double it. 6 times 3 is? 18 doubled is?
36.
And we got a 36x in the middle, don't we?
Yep.
So it does pass the test for being a perfect square trinomial. So we can say that that means they're both going to start with 6x. They're both going to end with 3.
Subtraction.
And they will have subtraction this time because b is negative. So we can write this as 6x minus 3 times itself.
Is that how you want to sort it?
Yeah, let's do just cleaning it up and writing it shortcut. And, like it's other name that kind of like is a shortcut, I guess you could call it. Again, is that a lot quicker than having to use the diamond method and factoring by grouping?
Yes.
Absolutely. Okay. But if all else fails, this doesn't work for you and you have to factor it because you got 14 problems to do of homework and 10 of them can be factored. So you can't come tomorrow saying that 5, 6, however many over 4 are not factored, and that's why you don't have answers for them. I'm going to say, well, you didn't work hard enough then. 10 of them are factorable, only 4 of them are not. Okay? Okay, questions, anyone? Okay, then let's get you to work on homework and get the fan going in here.